All right, and I'm going to stop my camera so that I don't have issues with my bandwidth. So, and during the course, when I'm just going through any point of time, if you have any questions, please feel free to put in chat or unmute yourself and ask about it. There's no question which is, I would say, is like very silly or very simple, because I have been doing this for quite a number of years, so some things which be very obvious to me may not be obvious to somebody who's new to the programming language. And I faced the same thing when I was learning for the first time. So I would really appreciate if whatever the really basic question and doesn't make sense, I will really encourage you to actually put either the question in the chat or just ask it, unmute yourself and ask it. I would be more than happy to help you out. You may be asking the question, but helping others to understand exactly the same thing, which I might have overlooked in explaining it. Okay, so my name is Vijender Singh. And I'm with the computational biology core at Institute of System Genomics. You can call me Vijay, or VJ is fine, whichever suits you. Hopefully you can see my slides because I'm sharing the slides. So, okay. Because in the morning, this so happened that I was sharing the slides, but slides were not shared. So if you don't see the slides being shared, just let me know. So these are the different topics we will be covering during the course of 12 weeks. Going to go give a really brief introduction, historically our introduction. So this is really important because a lot of people have put their time into it. And also to get an idea about how our programming or the Python programming are different, or the object-oriented programming is different from machine learning, what we call the machine language and other ones. We'll talk briefly about an R environment, talk about R packages, where you can get the packages. So the packages are generally a library of pre-written code to accomplish a given set of tasks. So basically you have a data, certain kind of data, and somebody has already written a code to analyze that kind of data. So for example, RNA-seq data, you want to do a differential expression, somebody has already written a package which can take RNA-seq data and do the analysis and give you differentially expressed genes. So you don't have to go and write your code right from scratch. You already have those packages, which are very well, some of them are very, very well supported by the developers, and has a good support. So if you face any issues, there are people who can help you out with that one. So those are the packages. There's a ggplot2, which is like another R package, really great one for doing graphics. So those are the packages. So they're already pre-written. You have certain kind of data, you want to do certain kind of function, whether plotting or analysis, there's already written code. So you use these packages and analyze it. And that's really the strength of R is. There are approximately, in total, if you think about somewhere around 20,000 packages out there, which you can, and if you are doing some sort of analysis, somebody has already written more or less a package which can take that kind of input data as input and can analyze and give you output. Most of the times you would be spending time is reformatting your data so that it becomes is in the suitable format so that it can be read in the package. Okay, we'll talk about basics of R objects. What are the different kind of data you can have in R? We'll talk about data structures, which is rather than having few elements, we have large number of like rows and columns kind of things. And what are the different ways you can store that kind of data? So those are the data structures. We'll try to talk about reading data into R. Could be you have your own data, maybe in the format of CSV file, Excel file, text files, tablet delimited files, or any other format. How do you import those data into R? So we'll go through that one. We'll go also we'll go through an exercise of looking and writing functions. Functions are sort of code which can be used again and again to perform exactly the same output. So we'll look into those ones. If any of those doesn't make sense, don't worry about it. I'm just going to go over these ones so that I explain what's the goal of the whole workshop is. But as we go along, most of this you will be able to understand. Control statements, when you have some sort of loops you have be writing or something like that. Group manipulations is an advanced version of, again, manipulating a table in certain ways. Data reshaping is like reorganizing your data. Manipulating strings, this is like You have names or character-based data and how you want to change it. That's you can use manipulating strings, especially clinical data. The clinical metadata generally has there's a lot of string manipulation goes into that kind of data sets. We'll finally look into statistics graphics using a basic R. So when you download R comes with basic functions of doing plots, but they had most of the times they don't have an additional functionalities, or you can say allow too much of control over how you want to do the graphs. So ggplot2 in that case is really a very good you can say package that allows a lot of control to the user to how they want to manipulate or generate the graphs. So we look into that particular package. This is one of the most commonly used package in case of generating graphs. If you finish early, I mean, say 12 weeks, you finish like a couple of weeks before, then we can go through some of the packages you guys are interested into. So we can look the specific codes or possibly some specific issues with respect to that code and how to use those packages. We can look into some of those examples. When you look at the different programming languages, the main criteria that defines a programming language is how far it is away from the hardware. So there are programming languages which are like machine language is very close to the hardware. And the advantage of that one is because it's so close to the hardware, or basically your RAM and your CPUs and other resources on your laptop, the code or the program written on machine language actually runs at much higher rate or faster rate. As you start, but then at the same time, the downside of these languages is they're very difficult to learn and develop expertise. So then people have worked and start developing some sort of programming languages which are much easy to write. And one of those ones are the object-oriented programming languages. And what object-oriented is, I will just talk about a little bit later, but R and Python falls into that particular group. So they're a little far away from hardware. So there is a very ease of writing the codes. The writing code is pretty easy, but at the same time, its execution can be slower compared to the same code written into machine language. This is not going to become very evident in our codes because most of our data is not really of the size that can give you a difference when you run the same data analysis in machine language versus you run an object-oriented programming language like Python or R. If you're running some millions of simulations, that's where the machine language possibly makes a difference. You'll see a time difference between something being running into machine language versus something running into object-oriented like R or Python. So from our perspective, generally the biology-based data sets, what we are using, whether it's a next generation data sets or whether it's a mass spec or any kind of metabolomics kind of data set, if you're analyzing, it's hard to basically notice any time difference or basically lag. It's going to be pretty much the same speed what we'll see in case of the machine language. Generally, there are not too many programs out there that are written into machine languages. Most of the time, if you find, could be written in C. Where does the R originated from? So originally, the language which was first created or basically written for statistical programming or data analysis was S. Was written by John Chambers in 1976 at Bell Labs. However, this particular language was license-based, so you have to pay some sort of subscription fee. So the two researchers at Rosh Ihaka and Robert Gentleman basically got together and then quite didn't like the as payment-based or the subscription-based method. So they basically put a goal and then sat down and wrote R. The first beta version is generally a testing version, which people are not really sure about whether it's going to work or not. So the beta version was released in 2000. After that, there is a core R development team, which actually works on R and then keep on improving in its performance. And now, if you look at R, you can get R to be installed in Linux, Mac, or Windows, doesn't matter. In all the three platforms, you can run R. The most recent version of R is 4.2.0. For any kind of release that is out there, they just end up giving some sort of a you can say, I don't know, it's called technical or funny, or they keep on giving some really weird names sometimes. So this particular version has been given vigorous calisthenics kind of name. It can be downloaded from the CRAN website. So CRAN is Comprehensive Archive Network. So this hosts the R code, the base R code. At the same time, it also hosts a wide variety of packages, which are not biology-oriented packages, or mostly statistical packages are actually on CRAN website. Biological related database packages are available on another database called Bioconductor, and that's from where we download these packages. These are some of the resources out there. R in Action is really great book. R for Everyone is also good. If you depends upon where your learning lies. If you're really a beginner, I would prefer or recommend R for Everyone from Jared Lander. That's why that's from where I have most of my, I won't say my examples are, but that's the pretty much the flow I am following for the workshop. These are the different websites out there if you want to learn a little bit more. It needs some sort of help. There's a Stack Overflow, there's a biostars.org blog website, and you can always email us. I'm more than happy to help in any kind, if any issues. If you just use R, or when you download R, the programming language, and if you click on it, it's going to open a window something like this. This is you can say it's a type of an R console. So when it opens up, it's going to tell you what version of R it is running. So for example, in this case, the version is 3.5.2, and the common name or some sort of funny name is Eggshell Igloo. So that's the kind of name they keep on giving every time they release a new version. And then it also gives you some information about how to get help, how to get a demonstration, and how to quit and other kind of stuff. Whatever the commands you execute in R, it keeps a record in history. And when you try to quit it, it's also going to ask you whether you want to keep a record of what you have done into the session. Finally, you see this cursor down here. So referred as a cursor or the prompt, that's where you interact with R programming. So you basically write a code or write a command to R, the R takes it, executes the code and gets the output, and then the output is displayed on the screen. We are not going to use the standard R interface, but what we are going to use is a IDE, which is an integrated development environment, which has a little bit more, you can say, additional help around it, and it looks much more organized and you can say that there's a much more organization goes around just having that, rather than having the R programming console on its own. So if you have installed R Studio and you invoke it, you end up seeing these 4 panes or 4 windows within the same main window. The organization could be very different from what you are seeing here, but invariably you will see these 4 windows. I'll talk a little bit about it when I open and show you the R Studio, what mine looks like. And then you can organize it. You can organize how these panes are, you basically can rearrange these panes or windows depending upon your convenience or what suits you. So it's very different from each, we can say, programmer to another programmer. What works best for one may not work the best for the other. So you can reorganize them whichever way you would like. If you have any questions during what I'm trying to speaking, just please let me know, okay? As I mentioned, that the main strength of R is the availability of packages. Basically, if there's some sort of data, there's a code already available, or the functions in a code is already available in form of a package that can take that data and analyze and give you the output what you're looking for. These packages are mainly available from 3 different locations. I have mentioned only 2 here, but there are 3. One of them is the CRAN website. So CRAN website generally hold most of non-biology related packages on the CRAN website. CRAN website is sort of like an open repository. So people end up putting their packages over there. Some of these packages are well maintained and some of those are not. So if there is a package that is available on CRAN website, there is no guarantee that that package is going to work 100%. So how do you know? How one knows which one to use? So it's generally you look into look on basically search on the internet or look at the publications, the kind of data you are analyzing. People might be using some sort of packages, so you get an idea about, okay, some researchers has used that package. Basically, that package is going to work for you as well. On the other hand, most of the biology-related packages are available on a website called Bioconductor. And here, this repository is again open, but at the same time, it's pre-reviewed. So anybody who develops code and forms a package and try to put it on Bioconductor, there are some strict pre-requirements. And also the code undergoes a pre-review. It's like pretty much like publishing a paper. So there is a group of developers who will go through the submitter's code or the package code. We'll also give suggestions with respect to optimizing the code. At the same time, the requirement is to have a help file all the time, so that any researcher who wants to look at that package has something to look for reference. So you always find a reference available to the for the packages that are available on Bioconductor. And thankfully, most of us are doing biology-based work. So any package we are looking at, most of them would be from Bioconductor, except few of those ones like tidyverse, dplyr, ggplot2. These are some of the packages which are either for graphics or data reorganization, which are not part of Bioconductor, but are on CRAN website. But then again, these are really heavily used and very, very well maintained packages. The third website, which I haven't listed, is from GitHub. So there's a good number of packages also there which are available on GitHub, and that researchers can download or possibly install on the R and use the code for their analysis. The code for that one I will talk in a while, how to do that one. So any of these packages you can, so to install CRAN packages, the command is install.packages and the package name. I will look into that one. This is just a presentation. We'll go and look into the R console, these commands again. In case of Bioconductor, the installation process of these packages is generally, you can say, controlled by a package called BioC Manager. So in order to install anything Bioconductor, first we have to install BioC Manager. Now this package BioC Manager, then what it does, it then help us to install all the other packages that are required, that we or help in installing the packages we need. The good thing about BioC Manager is this, that if you're trying to install a package and it has dependencies basically what it means is if you're installing package A, it may need package Y and Z to work properly. So BioC Manager will take care of that and install those ones as well. That can happen even into installer packages. But if there is a version conflict, BioC Manager sometimes can handle it much better and make it those packages to install properly on your R environment. We look into some of the examples of how to install packages. So R is an object-oriented programming language. So what are the object-oriented programming languages? So in a simplistic term, if I don't complicate things too much, an object-oriented thing is sort of like anything you have, any kind of data set, when you bring it to R, it is pretty much like a container. And R doesn't care what container it is. It's just like a box. It puts everything, dumps inside it, and then it just keeps a record of the attributes of that particular object. So when I say attributes, it's like how many rows, how many columns, what kind of data it is holding. And that's pretty much contained in that container. And that object is basically only used when you call for analysis. All right. And everything in R is an object, and everything you create, like any kind of variable, any kind of data set, any kind of a data frame, list, or anything you create, that is an object. I talked about having attributes and methods associated with a class. Is one of the functions to help you look some of the properties of an object. So this is really some basic thing, but if it doesn't make sense, don't worry about it. This is not going to affect your understanding of the rest of the R. This is the sake of just trying to tell you, give you some brief introduction. I have put in the slide over there. So you are pretty much done with respect to the introduction of R. So what we do now is I'm going to start an R Studio, and it will show you the interface. How does it look like? What are the different panes are there, and how you can reorganize if you want to reorganize based on your liking. So I think I had somewhere. It's not there. Oh, okay, see it. Okay. Now, when you okay, I have this. Okay. When you open an R Studio, this is how your window will look like. I hope my screen is still shared, and I'm right now showing you R Studio. If you can't see an R Studio, just let me know so that I can make sure that it is being shared. Okay. So these are four window, you can say panes within the same window. So 1, 2, 3, and 4. In my case, this is what I referred as the source. This is the console. So source is where I'm going to write my script, or basically the code I want to execute. Now, why would I? So let me go to the console and then I'll come back to that one. So this is the source where I can write my code or lines of code over here. This is the console. This is the same thing if you just directly invoke R. When I say invoke R, basically go on the R icon and double click and the window opens. That's what you're going to see over here. So if you look over here, this is the version of R I am using. So 3.5.2. It's a little old. And it's an Eggshell Igloo. Most of you, if you have installed recently, your version will be 4.2.0. So don't worry about that the versions are different, because the kind of operations or commands we'll be using is not going to make much of a difference between using a version 3.5.2 versus 4.2.0. They're going to be pretty much the same. So this is the console where you can actually execute commands over here. And once you submit the commands get executed and you get an output. So I can directly write a command over here, for example, the command called list.files. That's one of the commands, and it's going to list me all those files over there. I can do this, or I can write the same code over here, and I can execute this again. So I can select it, and then once I select this one and I say run, it's going to run the code and it's going to execute it here. Now, why would I like to do it here rather than doing on the console? One of the things is this way I can keep a record of it. I can save this file in wherever I want like to. So I have a record of what are the different commands I have typed. So at later point of time, I want to go back and look at it. I have a record of a documentation of it, what I have done with respect to a particular data. The other thing is if there are some issues in this, let's say I missed a comma in the whole command, I'm not going to go back and retyping a big command. I just make the changes here and then execute the code that way. So this is so in my opinion, always write your code on the source or in the file side and then execute it. When the organization of these 4 panes or 4 windows can be rearranged. And the way to do that one is you go to the view section, and there is an option called panes. You go in that one and then check on the pane layout. So once you look at the pane layout, it will tell you what right now what the configuration is. So in most likely you have console on this side and source on this side. I have just flipped it around. You can change that one. So you go on this one and select, okay, I want console on the left-hand side. And so you select console there. And I want basically source on this side. You can do that way. Or you can, then the lower, what you can say, panes, you can select which all to be listed on which side. There is no standard format to it. There is no recommendations with respect to, okay, what's the best ways? In my opinion, it entirely what works for best for you, you use that one. Okay, once you have made the changes or basically put the way you want it, just simply say apply, and then I think those panes will be rearranged based on how you like it. Okay. Okay, so now this is, in my case, this is the source side, which basically means there's a script which I'm writing, which is named untitled.2. And I write a line over here, and I want to execute this line, or basically run this line into console. So this is a script. I want to run it on the console. If I don't run it in the console, the command is not going to get executed. So I'm going to execute it. There are a couple of different ways you can do it. One of those ones is simply select and then do do run, as you have seen it. The other is you get your cursor to the line which you want to execute. So I want to execute line number 1. My cursor is blinking right at the end of it, but it doesn't matter. It could be in the middle, it could be at the start, it could be within the somewhere. And what you do is you press Control and hit return. So it automatically moves. The line actually gets executed on the right hand side. So just to show that it's working, I'm going to clear up my screen on the console side. So I'm going to hit Control and L together. It cleans up it. And now what I'm going to do is to execute this line. So it doesn't matter where I am in that code. I'm going to press Control and hit return. That line get executed. And automatically I move to the next line. All right. Okay, if you don't see your source window, okay, Amit, what I would recommend is, so whichever side, so basically you could see something like this, okay? Basically, or maybe let me try the other way around, okay? You may see something like this. You see a console, you can see this one, but you're not seeing the source window. Your source window is there, but just basically it's hidden. So what you do is double click on this icon with 2 windows next to each other. And it will basically, I think it will be open up. What it has been is squeezed or basically hidden by the other panel. So the side where you are seeing only 1 window, you should go and click on that 2 window icon, and it should be open up and split into 2. Hopefully that helps. Okay, let me know in the chat if it does. All right, cool. So that worked. So now we have everything organized with respect to that one. So the last thing which I want to talk about in RStudio is about projects. Now, this is my personal preference, and this is my personal as well as the recommended, I would say, method of doing analysis in R. You may have 2 or 3 different projects on which you are working. So keep the working space of each project separately, so that you have data from, you basically have all the scripts written for one analysis are separate at different location, and the other project is in another folder, and so on and so forth. So this is allowed in RStudio by having projects, the option of creating projects. So how do you go and create a project? So you go on Files, and then you're going to say create a new project. So I'm going to create a new project, and it's going to say whether I want to save my existing one, yes or no. So if you're already not doing anything, you can say don't save it. I'm not doing anything on this one, so I'm going to simply say don't save it. But then what it's going to give me is it's going to prompt me an option of creating this project into a new directory. That basically means it's going to create a directory, and inside that is going to create a project. But in my case, I already have data, or basically the teaching material already put into a specific directory. So I want to create this project there so that I keep on track. So this way I can keep a track of the progress I am making every week with respect to the course I'm teaching, right? So since the directory already exists, I would say just create the project, but create it in an existing directory. And then what it does, it is let me choose, okay, where is the directory where I want to create the project? So I'm going to browse it, and this is the morning one. So I'm going to go back and then choose from documents, and I can go in workshop R, and I will say, okay, this is the afternoon session. This is where I want to create it. So I select that particular folder, and I simply say open. So that's where the project will be created, and I will say create project. And now so suddenly what it does, it restarts the R. Okay, everything is get restarted now. And what you see is basically the contents of the folder where I am going, it has just created a project. Okay. When it creates the project, it gives the name of the folder. So for example, this is the project. If you can see at the right bottom pane, you can see that now there is a project file named .rproj, which is a project file. So now it's going to keep track of all what we are doing. Okay. I hope you have a similar folder where you might have put all the 3 files which I shared with you guys, 2, I think day before and 1 yesterday, or today morning, I think, something like that. But I have 3 files which I shared with you guys. So what we are going to do is we are going to invoke one of the files, okay, which is intro to r.r. So that's a script in a way, or you can say it's a documentation of what we are going to run. So I'm going to say file, I'm going to say open file, and it's going to directly take me to because in the project directory, and will ask me which one I want to open up. So there is this particular file, intro underscore to underscore r.r is the file I want to open. So that's a script which I'm trying to open it. So that's it. So that's what I see now. So that script has been opened. And we'll go through this. I go one by one and explain you the code. Now, the description of each of these codes is in the Word document, which I have shared with you. So if you go and have a look, okay, I don't have that one. Okay, so let me open and then show you what the Word document contains. So this is the Word document, and you can see these are exactly the same codes which we are going to execute, but there is a more description about each line. I don't have a description there because I'm going to be talking and trying to explain what's going on. But if some point of time you want to go back and refer to the material, the explanations are there for you to have it. So I hope everyone is having the R project done and they have their scripts open on their source window. And console window is pretty much clean. If it is not clean, that's also fine, no problem. So if you have done that, just give me thumbs up on the chat, or just say got it, or just say yes or done. So I will know that we all are everybody is set up to go through the exercise, and then I will keep on explaining the rest of the steps. So if you can put a short note in chat, it will be awesome.
Can I ask a quick question,
Sure,
Vijay?
anytime.
It says in mine that packages BioC manager and something else are required but not installed. Do we need to do that?
So we'll go to that one by one. So if you haven't done it, don't worry about it. We'll go one by one through all of those ones.
Okay.
Okay, so I'll go through this code one by one. So each of these code lines I want to explain, give you some idea about like what's going on.
Okay, sure.
Okay. I'll just give a couple of minutes so everyone actually invokes their R session at the same time, have this script on. So, yeah.
Hello.
Hi.
I just want to know, I just want to make bigger the alphabet size. So not, I think I can do it on source pane, but for another pane like environmental or other pane, can I make it bigger, the letter size?
I think if you hit Command and plus, it should make it bigger or smaller. Command plus will make bigger and minus will make it smaller. I think that should help you out.
But I'm using PC, so I don't have command.
Oh, okay. That's right. So can you have the window icon? Can you hit window and plus, or control plus? Can you hit control and plus?
All right, I'll try.
Try control plus. I think that should make it big. I'm sorry, I don't have a Windows machine to.
Yeah. Okay. Yeah.
Is it helping?
Yeah, with Control Shift and plus.
Oh, okay.
I think it is good. Yeah.
Okay, cool. So Control Shift and plus. Okay, that's good. Okay. If anybody else is struggling, the font is too small, you can make big and small based different ways. If you're using Windows, then I think Control Shift plus. If you're using Mac, then it's simply Command plus. Oh, right. Command plus. No. Sorry. Control. What happened? Okay, let me see. Command plus. Yeah. Command plus will make it big and Command minus will make it smaller. All right. Okay, so I think everyone has this basically open. So let me go one by one. So the first line, which is, this is downloading packages from CRAN website. So CRAN packages. So if you have any packages which you want to download, sorry, my spells are wrong. I don't know. Sometimes so if you are installing a package from CRAN website, the command you will be using is install.packages, and within the quotes, the name of the package. If you want to execute it, you can, but otherwise I would recommend you to do after the workshop, because the problem is some of these will take really long time to finish. Okay, so just let me go one by one, and we basically, so that after the workshop, we can use the basically code to run it. So if you want to run the code, you go to the line and control and enter, and it should be execute line on the left side. Okay. So the next one example is from GitHub pages. If you have any package you want to download from GitHub, you are going to use install.github. And now this particular command, install.github, it doesn't come with the R. So sorry, it is a part of another package. So before using that, you have to say install dot. The good thing about R is, again, you type a couple of lines, like words, and it will suggest you, okay, which one you want to use it. So I'm going to use install dot packages. So that's the selected one. So if I hit tab, it should pick it up. But if you want to use the other one, I can use my cursor keys to select between the two. Okay, up and down arrows, I can select whichever I want. So I want to use this one, hit tab, it auto now fills the space, and I am going to say here that I need DevTools. Okay, so you need to install DevTools before you can use install_GitHub. Okay, once you install that one, there's one more line you have to execute, which is called library DevTools. So what's happening in the line number 5? So in the line number 5, we are actually installing a package called DevTools, which comes from CRAN website. So that's why we are using install.packages. When any package when gets installed, that doesn't mean that now all the functions of it are available to you. It's something similar to like you can, when we install any application, or you can say program from outside on our laptop, we can install it, but just installation, it doesn't mean that, okay, it's installed and now it start working. Now you go to that particular one, or you double click it, you invoke it, you start the program, that's where it starts. So library DevTools is something similar, that, okay, install.packages has installed the application, or installed the package, but in order to use the functionalities of DevTools, you have to load it, or you have to start it. So the library DevTools is the function, is the command. Library name of the package is a command to use the functionalities of a given package. And once you have done that, then there is in DevTools, there is a function install_GitHub, and then you can install a repository which is on the GitHub. Now I have mentioned here as coef plot. The coef plot was initially some time back was on GitHub, but now it has become a part of a CRAN website. So it has been deposited on the CRAN archive or repository website. So it's no longer going to work. But the idea is, like any package you're trying to download from GitHub, you can use this kind of syntax or this kind of command, install_GitHub repo equals to coef plot. Okay. The other thing to remember is once you have installed a package and you're trying to, let's say, want to work on another project and want to use the same package, you don't have to reinstall it. Once installed packages will be available across all the projects you are going to be running. If you're doing 20 projects, doesn't matter. If you install the package one, you can load that package in all the 20 different analysis by using the command library DevTools. You have to use this command though. This is the command that will tell, okay, now load that particular package and basically make the functionalities of that package available to me in this project. So you have to use this particular command. Okay. The next one is from Bioconductor. So if you're trying to download any of the packages from Bioconductor, these are the commands you're going to use. So the first one, what is listed is for R versions less than 3.4. Okay. When R was in earlier development, I won't say the early development stages, but the versions of R less than 3.5, what it used to do for installation of Bioconductor packages was it is going to ask you to source one script called bioclite.r. So this script has certain functions. The functions are like installing packages and other thing. And once that is being, this line number 11 we have executed, then you use bioclite function from this script to install any package. So here we're trying to install Edge R in any R version less than 3.4. So right now, all of us are having more than, like, I'm pretty sure that for more than 3.5. So if we can't use this particular functionality, or it may not work, but the older versions, this was how it used to be. The most recent packages, or the R versions, which are greater than 3.5, and if you're trying to download a package from Bioconductor, this is the method to install a particular package. Okay, so let me just separate a bit. To install a package from Bioconductor, you need some functionalities, and that functionalities comes from another package called BioC Manager. So it's sort of like you're first installing a package management program, and that package management program will help you to do certain functionalities. Okay, so this code line number 17 and 18, what it is doing is, the first line is first checking whether if you have BioC Manager already installed. If it is not installed, it's going to install BioC Manager. Okay. Once you have BioC Manager installed, then you can actually use you can use the functionalities over here. Oh, sorry. Yeah, okay. The function is BioC Manager :install. That's the function of install function that comes from BioC Manager package, and that helps you to install a given package. Okay. So right now, if in my version of R, or in your version of R, if you're trying to install any Bioconductor package, the code you will be using is, first you are executing line number 17 and 18 to make sure that you have BioC Manager. And then you execute line number 22. Let's say that's what I'm trying to install. So I will say use the install function from BioC Manager and install this particular package whose version number is this. So I'm specifying a particular version. For some reason, if you're trying to interested only into very specific version, that's how you're going to specify the installation of a package. If you don't specify a version number, what it does, it picks up the most recent version of that particular package and is going to install it. Okay. Once this package is being installed, then you can call it, in a way you can say call it or make the functionalities of it available to you by using two different commands. One is require, and then you give the name of the package, or you can say library and the name of the package. Both of them pretty much do the same thing. There's a little bit difference between them. Require, what it does, it try to load the package, and after loading the package, is going to let you know whether it's successfully loaded or not loaded. If the package loading went successful, that's fine, great, everything went fine. But if you have some issues in loading the package, the require function just throws out only, sometimes throws out only true and false, basically telling you whether it's successful or it's unsuccessful, but won't tell you details about like what actually went wrong. So troubleshooting becomes a little difficult. Whereas the library Edge R is a more detailed, so when it's trying to load it, it's going to give you a lot of information about which packages it is installing. At the same time, it also sometimes tell you about certain what you call as a conflict of function names. So for example, let's say try library Edge R. So it's trying to load that one. So it loaded a Lima. Now I'm going to load one more package called dseek2. Okay. that I've already installed, so I don't have to go through the process of installing it. But if you're trying to install it, then you have to go through this particular process, BIOC manager, :install, and DEC2, and it's going to install it. So when I'm going to load it, it's going to throw me a lot of these messages, and hopefully it will give me something at the end, which I can explain. Okay, it doesn't have that one, which I'm looking for. Okay, let me try one more package. Dplyr. Oh. All right, okay, so I have to update rlang before I can use. Okay, I have to sort that one out. Maybe next time when we are meeting, I will let you know. Okay. So this is the how basically the library functions are the functions you can use to load packages. So for example, here I have loaded DEC2 using this particular code, and loaded Agile using this particular library function. Sometimes you have to unload or a given package. The function to use is called detach. So if you say detach edgeR, that particular program or that particular functionalities will be taken away, and no longer the functions will be available to you in that particular environment. So in order to use the functionalities of edgeR, after you have run detach edgeR, you have to run again library edgeR or require edgeR. Okay. Now these two codes are to basically explain what these double columns mean. In case of the packages that are being developed in bioinformatics or any other field, there is, when somebody writes a function in a package, there is no way for one to know whether that particular function already exists, that the name of that function already exists in some other, let's say, package or not. So for example, there's a coef plot. Coef plot has a function. There's a coef plot, what you can say is a function in package coef plot, which generally used in building regression lines or building regressions and other things, doing regression and finding the coefficients of the plot. I'm sorry. I'm so sorry. All right. But at the same time, there is a coef plot function in another package called R. If I'm running a code and for some reason, let's say I have loaded library ARM. So I have functionalities of library ARM. I have functionalities of coef plot. Right. So both of them are being loaded. So once I have loaded both ARM and coef plot, the problem is both of these and I want to use, let's say, the function coef plot, which is a part of, you can say coef plot, the package coef plot can do multiple things, but one of the function it does is finding the coefficients of your plot. Okay. And I want to use this coef plot. How I'm going to specify that I don't want to use the coef plot function from ARM, because that might be doing an entirely different thing than what I am expecting. Okay. So in order to specify that the coef plot I am trying to use is from a one specific package, you use this specific double colon. So you specify the name of the package first, you use double colons, and then you're going to say the name of the function, and then whatever the data it takes it. Object basically specifies the input data. So in line number 34, if I'm using this code, what it basically means that I'm trying to use coef plot function coming from the ARM package. In the line number 35 is an example where I'm trying to use the coef plot function from the coef plot package. So the double colons help basically help R to identify where the particular function is coming from. So it may not be evident now, but for example, if you start doing loading tidyverse, lattice, and all those kind of packages for doing data manipulations, When you load a package, it will tell you, okay, what are the different packages which has the same name between two, what are the functions that have same names between different packages. In those scenarios, if you're trying to use a particular function, then you have to specify, okay, you're using this function from which package. You have two options, or two or three options, and that's the way you're going to specify. I hope this makes sense. If not, just let me know. I'm happy to explain a little bit more about it. Any questions on packages? And as I mentioned that all these packages has to be installed only once for the same version of R. So for example, if at some point of time you decided to upgrade your R from 4.2.0 to, let's say, the newer version 4.5.0, then what happens? You have to install all these packages again. So between two R versions, the packages has to be get reinstalled. But within the same R version, for example, what I have is 3.5.0, if I'm correct, 3.5.2. I can use the same R across different projects. Once I have installed any package, I don't have to reinstall it. I can simply use the package by simply saying library and the name of the package. But let's say I today decide, okay, 3.5.2 is a little old, I want to go to 4.2.0, then I have to end up installing all my packages again, because that's the older version. Packages I installed with the older version of R will not be compatible with the newer version of R. So that's definitely you have to keep in mind. Right? Any questions? All right, there's one, which is good. Okay, I'll just give you an example. Let's say, for example, I am developing a package called, let's say the package I am developing is called package1. Okay, and some other user, or basically across the different lab, there's another guy, he's developing a package called package2. So we have two different packages. Mine is package1, his is package2. We both are trying to do some sort of QC on, let's say, fast Q files, a certain kind of data set. So I write a code, fast QC, I write a function, fast QC, and my fast QC function, what it does, it takes the fast Q files and basically look at the read length. So FASTQ file holds the next generation sequencing data. So it looks at the read length and then calculate GC score from there. All right, so that's my FastQC function does. At the same time, the guy who is two labs down and writing it, he also thinks, okay, I want to do some sort of a QC on my FASTQ files, and he writes a function again, FastQC. And what his function does is it calculates it basically does a read length distribution or some sort of, let's say, statistical analysis on the lengths of the read for some reason. And we both submit our packages to the CRAN. They're there, and some user downloads, okay, for some reason he wants to use, and I have other functions also other than FastQC. So he loads my package, package1, and he loads the other user's package, package2. So both the packages are loaded. Now, it's important for the user to know, okay, he wants to use a FastQC function. Now, he wants to use the FastQC function to calculate GC score. Now, that FastQC function is actually from package1, because the package2 FastQC actually does is with some sort of statistical analysis on read length distribution. So in order to specify that, okay, the FastQC the user want to use comes from package1, so he's going to say package1 : FastQC and then the input data. So then what happens? The FastQC function from my package or package1 will be used to run over the data, and it will going to give you GC content. If you don't do that, then it basically going to work. It may give you, it may not give you based on when you have installed which package. Okay, hopefully that makes sense. That example makes sense. Otherwise, I will come next week. Basically, next week when we are meeting, I can come with a good example of that one. Yeah. So, but that's the simplest way of telling, like, okay, two fast QC functions coming from two different packages, doing entirely different thing. It just happens that the name are same. You can think about bioinformaticians are not really good or innovating in thinking names, but at the same time, we want to keep these names as less complex, self-explanatory as possible. So sometimes there's a conflict in the names, and these functions can end up doing entirely different thing than what one would be expecting it should do. Okay. All right. So the next set of lines, if somebody is keeping track of the time, will be awesome, because I can't, because my windows are all covered with stuff around. All right. Okay. Oh, we're close. Close to like 3 o'clock. That's also strange. Okay. Anyways. So the next set of codes from 38 to 49 is sort of some mathematical calculations generally you can perform in our environment. These are not really useful, to be frank. I mean, see, this is anytime you go to any programming language workshop, they will show, okay, this programming language can work as a calculator. So the same R can work as a calculator. But that's not what you're here for. But then again, at the same time, trying to show you how to do different arithmetic, you can say, operations. That's the main purpose from line 38 to 49 is. So I will go through one by one, and that's pretty easy to follow. So I'm going to hit Control and L. That will clear up my screen or the console. So the first line is 38. So I move to that particular line and hit Control and Enter. You can as well write the code if you would like to, 2 + 1, and hit Return. It will going to give you 3 as an answer. Now you can notice that there is a space over here between 2 and plus and 1. Whereas when I wrote in the console, I don't have. So the space is optional. You can put it, or you cannot. If you do want to put it, you can put it. If you don't want to, that's fine. Sometimes giving space between these, the code looks much neater. So maybe worth trying. So the first is addition. So I'm going to execute. Okay. And it adds 2 + 1 and gives the output as 3. Now you can see there is this hash character or the pound character followed by some, just I'm trying to put a note that, okay, this does addition. So anything that is followed by a pound sign in a code is generally considered as a comment and is ignored by the R base or the R, you can say, operating language. That any command, most of the like Python and R, Python R Linux has pound as a ways to tell the system that anything following this pound is a comment by the user for himself or herself. So it doesn't have to be executed. So that's why it ignores plus addition. Otherwise, it could have given us an error. So for example, I'll go to the console, do the same thing. And this time I'm going to remove this pound sign. And if I do, it's going to tell me that, okay, there is an error here, because it tried to take addition as some sort of a code it has to execute, and it can't figure it out what it has to be done. All right. The division is 4 divided by 2. Gives answer 2. 7 divided by 2 is going to give you 3.5. It's a decimal values you can get. If you want to just get basically an integer part of the division, like the output you want is without the decimals, you can put %/%. And that will, what it does, it will only give you basically what you can say, forgetting it's a complete numbers, but it's not going to give you, or integers is going to give you, it's not going to give you float values or the decimals. Right. Same thing you can do is subtraction. 2 - 1, 1 - 2 is going to give -1. There are sometimes the need of when you want to get only the full integer values, you don't want decimals, specifically when you expect that the decimal values doesn't make any sense, kind of stuff. All right. There could be data sets out there which will be sometimes. Can have multiple values added up, 1 + 2 + 5. So I'm hitting Control and Enter. So anytime I hit Control and Enter, it executes that line, and the cursor automatically goes to the next line. All right, so next one is the multiplication. So 4 star is the multiplication. So 4 star 4 is 16. You can do pretty much like an arithmetic calculations, 4 star, and you can have these things to be added before. Otherwise, what it's going to do is going to multiply first and then add. So it's pretty much follows whatever is the operation senior or operation preference, like division and multiplication followed by addition and kind of stuff. If you put 2 stars, that basically means 2 to the power 3. So this is 2, and 2 stars basically means it's an exponent. So 2 to the raised to the power 3 is 8. That's what it's going to give an output. You can have fractions. So 16 raised to the power 1 by 2, which is like 0.5, which is pretty much like square root of 16. So that's actually is 4. Or you can have the same way. The output of both of those are pretty much the same. There's not much difference between the two of those ones. It's already like an hour we are inside this one. There are other things is the important thing is not, okay, these mathematical calculations, that's how you can do it. But the main idea is if you're doing these mathematical calculations, you will be doing on your data set. Once you're doing in your data set, you want to store those values for use in future. For example, if you have read counts coming from 2 different samples, you want to somehow normalize based on the total read count. So you want to do the sum of the read counts from sample 1 and read counts from sample 2, and then you divide by them so that you have a scaling factor. That scaling factor, you don't want to just you want to store it, because otherwise, once you do this operation, the output comes, the output is displayed on the screen, but after that it's completely destroyed, or basically there is no way you can call it back. The only way to call back is to do this operation again. Now this is pretty small one, but if you're trying to do some big operation like summing up of the rows and let's say calculating standard deviations and then sort of all sort of things to get one particular value, it's better that if taking some time, it's really advisable that we store that value in some variable so that we don't have to do this operation again. And it saves our computational resource and we can use it later. So the best way to do that one is we assign these outputs to certain variables, and then we should be able to, we call these variables later in the script to use them. I think we already like an hour inside, hour and 5 minutes. So I'm going to stop now. And basically, if you have any questions, please let me know. This is really basic right now, and I want these things to be really fundamentally clear what we are doing before